Okay, I'm going to start off by saying that you really need to pay attention to this. If you're just letting it play, there's not really any point in watching this because you're going to get really confused really quickly. But it's not that bad if you just pay attention and follow the steps, okay? So we've talked about system of equations in 2 variables, but now we want to talk about systems of equations in 3 variables. So instead of an ordered pair xy solution, we will have an ordered triple, which is an xyz solution, which means if you graph on an xyz plane, it's 3-dimensional. And so they're talking about planes here, but just to kind of show you, if you graph this, it's like this is the, it's like flipped down. So this is the x, this is the y, this is the z. Isn't that pretty cool? And in pre-calculus, we'll graph on the xyz plane a little bit, which is kind of cool. Calc 3, I graphed on the xyz plane. But basically, you can have the same kind of solutions as when we graph 2 dimensions. One solution is that, like, if 3 planes intersect in exactly 1 point, that would be one solution. No solution would be, there's 3 different options. One, they could be parallel planes, but also maybe 2 of them intersect, but they all 3 don't intersect at the same point, so those are all no solution. And then infinitely many solutions would be if they intersect in a line. So if all 3 intersect in a line, that's infinitely many solutions, or if they're all the same plane, right, then there'd be infinitely many. So we're going to start with a nice easy one of, although this has 3 letters, A, B, and C, each equation doesn't have all 3 letters in it. And so we could start really easily on this one, right, that you could just solve the first one. That you could just say, well, A equals -2. And if A equals -2, I can kind of just do some substitution, right, and plug that in here. So that would be -10 plus 2c equals 0. So 2c equals 10 and c equals 5. And then really nicely, I can plug that into the third equation here and get 7b plus 15 equals 22. And I can subtract 15 over, right? And that's 7. So then b equals 7. And you can just circle your answers like that. Or if you're going to write your answers, make sure you put them in alphabetical order, A, B, and C. And if you check them all in those equations, it does work. Now, this is not going to happen a lot where you have something so simple, but it is one that can happen. More than likely, you're going to see something like this. So I kind of wrote it out in steps for you. So 3 equations in 3 variables. We can't solve this all at once, okay? So we have to take some steps. So step 1 is you want to use elimination to make 1 letter drop out in both equations. So we're going to do elimination to make 1 letter drop out. And this is where you have choices. So you want to look at this and say, which one looks like the least amount of work? Could I make my x's drop out, my y's drop out, or my z's drop out? And sometimes there's a more obvious choice than the other. For me, it looks like z's would be the best choice on this, because look at the first equation and the third equation. They both have a 2z in it. So I'm going to make the z's drop out. So I'm going to take those 2 equations. So I have 5x plus 3y plus 2z equals 2. And I have x plus 4y plus 2z equals 16. And since they're both plus 2z, I need to subtract these, right? And so it helps me to put the subtraction sign all the way through. Some of you guys are really good and you just kind of keep track of it. But it helps me if I put it all the way through. So 5x minus 1x is 4x. 3y minus 4y is -1y, or just y. And 2z minus 2z cancels out. And so 2 minus 16 is -14. Notice I still have an x and a y, but I've at least got it down to like what we're used to doing. I have to do this twice, right? So we have to use elimination to drop out 1 letter in 2 equations. So you have to do this 2 times because we need 2 equations. So here's the big thing. You must go back and use the equation that you haven't used yet. So we have to use this equation again, but then it's up to you whether you want to use the top one or the bottom one. And on this one, since they're both 2z, it doesn't matter. So I'm just going to use the top 2 equations, which means the top one I'm going to do nothing with. And that's going to stay 5x plus 3y plus 2z equals 2. But on the bottom equation now, I'm going to multiply by 2 because I need those z's to drop out, right? So that's going to be 4x plus 2y minus 2z equals 10. And on this one, look at the signs. Plus and minus 2z automatically cancel out. So that means I'm adding these two equations. So that's just going to be 9x plus 5y equals 12. I haven't really solved anything yet, but I have gotten rid of the z, right? So now step 2 is I'm going to solve this system, right? I'm just going to rewrite it here so you can see it. So I have 4x minus y equals negative 14, and I have 9x plus 5y equals 12. And this is what we've been doing all chapter. You could do substitution or elimination here. I'm going to do elimination, and I'm just going to multiply this top one by 5 to get 20x minus 5y, right? Is that 70? Five times 10 is 50, and 5 times 4 is 20, so that's negative 70, right? Sometimes you just question yourself too much. And now, am I going to add or subtract these? Well, since they are different signs, I'm just going to add. So I get 29x equals negative 58. So divide by 29, and I get x equals negative 2. And just like we've been doing before, if x equals negative 2, I can take that and plug it back in to find y. So I would get 4x minus y equals negative 14. So negative 8 minus y. So if I add 8, I get negative y equals negative 6. So y equals 6. That's solving the system. And then my next step is now use those equations to find the last one, right? And so I made this a step 3 for you. But if x equals negative 2 and y equals 6, x equals negative 2 and y equals 6, then I can find z now by going back to the original problem. I really wish I could double page this, and solving this. And you can plug it in any one that you want, all right? So I'm just going to plug it in the top one. 5x plus 3y plus 2z equals 2. And I know that x is negative 2 and y is 6. So negative 10 plus 18 is 8. And if I subtract 8 over, that gives me negative 6. So z equals negative 3. And you can write it like this, or you can write it as an ordered triple. And what I always do, even though sometimes I find out that I'm wrong, is I take those 3 answers and I make sure they work in all 3 equations, because then that tells me if I'm correct or not. And that's the answer, okay? So I have another one here that we're going to do this one in class, but I want you to start it, or maybe we should do the story problem in class. Where am I on time? Oh, 8 minutes. Okay, I'll do this one. So on this one, what would you choose? Would you choose to get your x's the same, your y's the same, or your z's the same? It's kind of up to you on what you do. But for me, I saw my z's right away, that I could multiply this top equation by 3. And I'm going to write it right underneath this bottom equation. And I would get 6x plus 3y minus 9z equals 15. And notice I kept them, they're the same sign. So in order to eliminate them, that means I have to subtract. So this will become a positive. And I do that every time. It really helps me. But look what happens on this one. This cancels out. This cancels out. This cancels out. This cancels out. So I get 0 equals 0, which means that the answer here is infinitely many solutions. Now this doesn't happen a lot, but it does happen. It means that they're either intersecting in a line, or it means that they're all parallel. I mean that they're all the same plane. So then, this is a story problem with 3 equations and 3 variables. And so it says, Heather downloaded some TV shows. A sitcom uses 0.3 of a gigabyte of memory, a drama 0.6 of a gigabyte, and a talk show 0.6 of a gigabyte. She downloaded 7 programs totaling 3.6 gigabytes. There were twice as many episodes of the drama as the sitcom. Write a system of equations and then solve it. So what I would like you to do is figure out what are our 3 variables and see if you can come up with 3 equations, and then we'll start there in class.